All right. So you're a programmer who's interested in machine learning, but you're maybe not an expert yet. We get it.
Yeah.
Today, we're doing a deep dive into knowledge distillation, a paper by Jeffrey Hinton and
Hmm.
his team at Google.
Right.
Um, and this paper explains a fascinating technique to improve machine learning models.
Yeah.
Think of it like passing down wisdom from a seasoned mentor to a promising new recruit.
It is a little bit like that. Yeah, this paper is all about making smaller, faster machine learning models without sacrificing accuracy.
Okay, so why is that important? I mean, we've got tons of computing power these days.
Yeah, that's true. But think about it. You wouldn't want to run a huge resource-hungry program on your phone just to do something simple, would you?
Right.
It's the same with machine learning models. We want them to be lean and efficient, especially if we're thinking about applications on mobile devices or in real-time systems.
Makes sense. So how do they achieve this distillation of knowledge?
Yeah. So the key is to start with a large, complex model that's already been trained extensively, and we call this the teacher model.
Okay.
And this teacher model doesn't just spit out predictions, it also gives us probabilities for each possible outcome.
So it's not just saying this is a cat. It's saying I'm 90% sure this is a cat, 5% sure it's a dog, and 5% sure it's something else.
Exactly. And that extra information, those probabilities are incredibly valuable. They capture the teacher model's deeper understanding of the data,
Okay.
its confidence levels, and even potential areas of confusion.
Interesting. So how does the student model come into play?
So we train the smaller student model not just on the original data, but also on these probabilities generated by the teacher. It's like the student is learning from the teacher's experience,
Hmm.
gaining insights into the subtleties and nuances of the problem.
I see. So the student model is essentially learning to mimic the teacher's thought process, not just the final answer.
Precisely, and this allows the student model to generalize better to new data, often achieving comparable accuracy to the teacher model while being significantly smaller and faster.
That's pretty impressive.
Hmm.
Is there anything else that makes this distillation process special?
Yeah, the paper introduces a technique called temperature scaling, which makes the teacher's probabilities even more informative.
Temperature scaling. How does that work?
So think of it like adjusting the contrast on a photo by tweaking a parameter called temperature. We can smooth out the probability distribution, revealing subtle details and relationships that might be missed otherwise.
Okay, I think I'm starting to get the big picture here, but the paper also mentions something called specialist models, right?
Yes, those come into play when we're dealing with very complex tasks, like recognizing thousands of different object types.
I can imagine that gets tricky, especially when some of those objects are very similar.
Exactly. That's where specialist models come in. Instead of having one giant model trying to do everything, we train multiple smaller models, each focused on a specific subset of categories.
So it's like having a team of experts, each with their own area of specialization.
That's a good analogy. These specialists are trained independently and then combined with a general model to make the overall system more accurate and robust.
This is all starting to sound pretty powerful.
Yeah.
But how does this actually apply in the real world? Where are we seeing knowledge distillation being used?
So one area where it's having a big impact is in mobile and embedded devices. These devices often have limited processing power and memory, so running large models is simply not feasible.
Mm-hmm.
Knowledge distillation allows us to create smaller, more efficient models that can run smoothly on these devices without compromising too much on accuracy.
So things like image recognition or voice assistants on our phones.
Exactly. But it goes beyond that. Knowledge distillation is also being used in areas like federated learning, where multiple devices collaborate to train a model without sharing their raw data.
That sounds interesting. Can you tell us a bit more about that?
Yeah.
Yeah.
Sure. Federated learning is particularly useful for privacy-sensitive applications like in healthcare,
Yeah.
where sharing raw data might not be feasible. Imagine you have a bunch of smartphones, each with its own personal health data.
Hmm.
Instead of sending all that data to a central server,
Right.
we can train a model locally on each device and then use knowledge distillation to combine the insights from all those individual models into a single, more powerful model.
So each device learns something from its own data,
Right.
and then they share their learning with each other without actually revealing the data itself.
Exactly.
That's pretty clever.
Yeah, it is. And this approach has a lot of potential in areas like personalized medicine, where we need to leverage data from many individuals while still respecting their privacy.
This whole idea of distilling knowledge sounds almost magical.
Mm.
Are there any limitations to this technique?
Of course, it's not a silver bullet. One limitation is that the success of knowledge distillation depends heavily on the quality of the teacher model.
Okay.
If the teacher model has biases or inaccuracies, those can be passed on to the student model.
So garbage in, garbage out, as they say.
Exactly. It's crucial to start with a well-trained and reliable teacher model. Another challenge is that while distillation can make models more efficient, it doesn't necessarily guarantee that the student model will be as accurate as the teacher model.
Right.
There's often a trade-off between efficiency and accuracy.
So it's like choosing between a fast but slightly less accurate model and a slow but more accurate one.
Yeah.
It depends on the specific application, I guess.
Precisely. And there are ongoing efforts to minimize this trade-off, to develop techniques that allow us to create student models that are both efficient and highly accurate.
It sounds like there's still a lot of active research in this area. Where do you see knowledge distillation going in the future?
I think we're just scratching the surface of what's possible. One exciting direction is the development of new distillation techniques that go beyond simply mimicking the teacher model's outputs.
Okay.
We're starting to see approaches that try to capture the teacher model's reasoning process itself, its internal representations, its understanding of the underlying concepts.
So instead of just learning what to predict, the student model is learning how to think.
In a way, yes, this could lead to more adaptable and robust student models that can generalize better to new situations, even those the teacher model hasn't seen before.
That sounds pretty revolutionary.
It has the potential to be, yes. Another exciting area is the intersection of knowledge distillation with other machine learning techniques like multitask learning and transfer learning.
Can you explain those a bit?
Sure, multitask learning involves training a single model to perform multiple tasks simultaneously, like recognizing both images and text.
Okay.
And transfer learning is about leveraging knowledge gained from one task to improve performance on a different but related task.
So it's like using your skills in one area to learn something new more quickly.
Exactly. By combining these techniques with knowledge distillation, we can create even more efficient and powerful models capable of learning from diverse sources of data and adapting to new challenges.
This is all incredibly fascinating. But I'm also curious about the broader implications. What kind of impact could knowledge distillation have on society as a whole?
I think it has the potential to democratize access to AI. By making models smaller and more efficient, we can run them on less powerful devices, making them accessible to people who might not have access to expensive hardware or cloud computing resources.
So it could bring the power of AI to more people in more places for more purposes.
Exactly. And that could have a profound impact on fields like education, healthcare, and even personal productivity. Imagine having personalized AI tutors on your phone or AI-powered medical diagnostics available in remote areas.
Those are some pretty exciting possibilities.
They are. And it's important to remember that knowledge distillation is not just a technical tool. It's a new way of thinking about learning, about transferring knowledge, about creating intelligent systems that can augment human capabilities.
That's a powerful thought. It's not just about the technology itself, but about how we use it to shape a better future.
Precisely. And as we continue to develop this technology, it's essential to consider its ethical and societal implications to ensure that it's used responsibly and for the benefit of all humankind.
This has been an incredibly insightful conversation. Thank you for sharing your expertise with us.
It was my pleasure.
And to our listeners, thank you for joining us on this deep dive into the world of knowledge distillation. We hope you found it as enlightening as we did. So we've covered a lot of ground here, from the technical details of how knowledge distillation works to the potential impact it could have on society as a whole.
Right.
As we wrap up, I'm curious to hear your thoughts on what the future holds for this technology. What are some of the key challenges and opportunities that you see on the horizon?
Well, one of the biggest challenges, as I mentioned earlier, is minimizing that trade-off between efficiency and accuracy. We want to create student models that are not only small and fast, but also highly accurate and reliable. And there's a lot of active research focused on developing new distillation techniques that can achieve this balance.
What about the ethical considerations? As AI becomes more powerful and pervasive, there are growing concerns about bias, fairness, and transparency. How can knowledge distillation help us address these concerns?
Yeah, that's a crucial point. And one of the advantages of knowledge distillation is that it can actually make AI models more interpretable and transparent.
Okay.
By distilling knowledge into smaller, simpler models, we can gain a better understanding of how they work and what factors they're using to make decisions. This could help us identify and mitigate potential biases or unfairness in the system.
That makes sense. If we can understand how the model is making its decisions, we're in a better position to ensure that those decisions are fair and equitable.
Exactly. And there's also ongoing research into developing techniques for distilling fairness itself, for training student models that are explicitly designed to be fair and unbiased.
That's encouraging to hear. It sounds like knowledge distillation could be a valuable tool for building more responsible and ethical AI systems.
I believe so, but it's important to remember that technology is just a tool. It's up to us as humans to use it wisely and thoughtfully. We need to be aware of the potential risks and challenges, and we need to work together to ensure that AI is developed and deployed in a way that benefits all of humanity.
Well said. I think that's a great note to end on. Any final thoughts for our listeners before we wrap up?
I would just encourage everyone to stay curious and engaged with this rapidly evolving field. AI is going to have a profound impact on our lives in the years to come, and knowledge distillation is one of the key technologies that will shape that future. The more we understand about it, the better equipped we'll be to navigate the challenges and opportunities that lie ahead.
Excellent advice. Thank you so much for sharing your insights with us today. It's been a truly fascinating conversation.
It was my pleasure.
And to our listeners, thank you for joining us on this deep dive into the world of knowledge distillation. We hope you found it informative and inspiring. Until next time.